Hey everybody. Today we're going to be talking about the last of the big three transformations, and that is going to be all about rotations. Let's see if I can get this to focus. There we go. Okay. So yeah, rotations. So we've talked about shifts, we've talked about flips, and now we're going to talk about twists. Okay, so here we go. A rotation. A transformation that results in a twist. There's an angle direction and center of rotation. And this also preserves congruency, just like the previous two. So in other words, our image will be the same shape and size as the pre-image. This got cut off a little bit. This should say direction of rotation. And this is actually the center of rotation down here. Okay, here we go. Center of rotation is going to be the point by which the rotation is made. And then the angle of rotation, so this is the center of rotation here in the example. We have a pre-image. It is twisted this way, so this would be clockwise. That's the direction, right? And this is the amount of degrees, the angle of rotation, and this is the point by which it's rotated. So angle of rotation is going to be the degree by which the rotation is made. And direction is going to be either clockwise or counterclockwise. Okay, so that's basically how it happens. We have a pre-image, we rotate it in a given direction about a center of rotation, and we also rotate a certain number of degrees, okay? And in this example, we're rotating this pre-image clockwise 55 degrees. Okay, so down here, there's going to be a few different rotation rules we need to remember. So I always have a really hard time remembering these. I always have to look at them for whatever reason. So this is 90 degrees clockwise, which is also going to be the same as 270 degrees counterclockwise, because they're both going to result in the same thing. If you go 90 degrees, excuse me, if you go 90 degrees one way or 270 degrees the other way, you're going to end up in the exact same spot. Okay, so this is the rule. We're going to say xy becomes y opposite x. Okay, and I'm going to write that here. So y opposite x. So we're going to go ahead and apply that. So P prime, Q prime, and R prime. So we're going to switch their positioning, and then the new y value will change signs. So 0, -3 will become -3, 0, because 0 can't change signs. 1, 1 will become 1, -1. And 4, -1 will become -1, -4. Now let's go ahead and graph that. And again, you want to use a pencil for these. I'm just using a pen so you can see it a little better. So -3, 0 would be 1, 2, 3 right here. And that's P prime. 1, -1 would be, right? Sorry, 1, almost did that wrong. 1, -1's down there. There we go. That's Q prime. And then -1, -4 would be 1, 1, 2, 3, 4. And that's going to be our R prime. And there you go. So if you actually rotate it 90 degrees clockwise, it's going to go that way. And you can actually turn your paper, and you'll see that it's going to end up where you drew it. So you can tell it worked by doing that. Rotating the paper is actually quite useful. Okay, so let's go ahead and look at the next one. So I think this one there's a typo, if I remember correctly. Yeah, we're gonna go ahead and fix that. So cross that out. That's going to be 180 degrees. And the direction doesn't matter because, yeah, 180 degrees in either direction will be the same spot. So the rule for this is going to be opposite x, opposite y. So we're going to write that here so we don't forget. It's always a good idea to write the rule multiple times. So let's go ahead and change those signs. So p prime is going to be 0, 3. Q prime is going to be -1, -1. And r prime is going to be -4, +1. Now we need to graph those. So 0, 3, 1, 2, 3. That's p prime. Q prime is -1, -1. And r prime is -4, 1. That's r prime. Let's go ahead and do that. So if we take a look at that, and you rotate 180 degrees, right, so that's exactly where it ends up. So you can tell it works. Okay, last one here. So we're going to do 90 degrees counterclockwise. So now it's 90, but now we're going the opposite direction. And we're going to go ahead and write the rule here. So it's going to be opposite y, x. Okay, we're going to write that right here. So opposite y, x. We're going to go ahead and apply this. So p prime, q prime, and r prime. Okay, so we're going to swap them and change the sign of the new x variables. So we're going to say -3 goes here and it changes to +3, and 0 switches where it is. 1, 1 will become -1, +1. And r prime, this is going to go here and change signs, so this will become 1 and 4. Let's go ahead and graph that. So 1, 2, 3. And that's going to be p prime. And then -1, 1. So right here, that's going to be q prime. And 1, 4 would be right here. And that is r prime. Okay. And that makes sense because you rotate it that many degrees that direction. We're good. Awesome. Okay. We're going to have to refer back to this for these. So determine the rotation of each figure. So you can actually do this two ways. You can look at it and say, all right, well, this is clear 180 degrees because it's actually 2 quadrants away. Let's go ahead and check something, though. Let's go ahead and use the coordinates. We're going to use z, the pre-image, and go to z prime. So z is going to be 1, 2, 3, 1. So 3, 1. And z prime is -3, -1. And we notice that neither number was moved, but they changed the sign. So when you have opposite x, opposite y, that's 180 degrees. Here, this looks like a rotation this way, so that looks like 90 degrees clockwise. I'm going to go ahead and write that down because I feel very confident about that. But let's go ahead and check it with the coordinates. So we're going to go with d to d prime again. So d is going to be 1. Let's not do d actually. Let's do one where, yeah, let's do c actually. And I'll explain why in a second. So c is going to be 2, -3. And then c prime, I'm out of room. C prime is going to be -3, -2. So this looks like they swapped. So x and y swapped. And this changed signs. So let's go make sure that's the rule here. So I have 90 degrees clockwise as my guess. And yep, that is the rule. So there we go. All right, here we're gonna do what we did over here actually, so we don't have a graph. So let's go ahead and pick. I want to pick ones where the numbers are different, so you can tell if they get swapped. So we're gonna go with y and y prime. So they switched, and this became opposite signs. So this became opposite y x. So let's go ahead and check, see which one that is. That is going to be 90 degrees counterclockwise. So 90 degrees counterclockwise. Lights came back on. That's nice. Okay. And then here, let's go ahead. Now this is a little tricky because I guess we'll go with G. So G and G prime, both of their signs changed. So if both the signs change, you know it's 180 degrees. You just know that's the case if both signs changed. Okay, opposite x, opposite y. And here you're going to actually rotate them. So I'm going to let you guys do those. I don't want to do those for you. I want you to do those on your own, actually. Let's go ahead and look at the last part. So rotational symmetry. Rotational symmetry is interesting. It's actually kind of related to what we did at the end of the last section here. So rotational symmetry. I'm almost out of time, but I think I can fit this in. If a figure can be rotated less than 360 degrees about a point, I'll zoom in a little bit, about a point, so that the image and the pre-image are indistinguishable then the figure has rotational symmetry. Now that sounds complicated, but it really isn't once you see what I'm talking about here. The order rotational symmetry is the number of turns it fits, which will make sense in a moment once we explain it. And the magnitude is the number of degrees with each turn. Now what does that all mean? I'll show you. So this is an example of a figure that has line symmetry. You can draw a line down it, but it does not have rotational symmetry. You cannot rotate this figure less than 360 degrees and have it fit upon itself. Okay, you can almost think of it like a cookie cutter, where you press the cookie cutter down into dough, right? And you have this cookie, right? And you take the cookie out, you have a hole. If you were able to rotate that cookie and place it back down in the hole, and you rotated it less than a full 360, you'd say that it has rotational symmetry. This triangle is a good example. If you have this triangle here and you were to rotate it, you could rotate it in a way where it would actually fit upon itself, and it's less than 360. Each of these points here, actually, each of these vertices is a spot in which it would work. So you could rotate this and it would fit 3 times. So the order would be 3, right? You can see this. And then the magnitude, well, it's real simple. You take the order, you take 360 and you divide it by the order magnitude. Did I spell that right? Yeah, I spelled it right. And that's going to tell you what the magnitude is. So if I take 360 degrees and divide it by 3, it's going to be 120 degrees, and that would be the magnitude. Okay? I'm not going to do the rest of these because I want you to try these. I think it's kind of fun. It's almost like a puzzle. So anyway, that's that. I hope that explains rotations. And yeah, I'll be posting some homework and some more instructional stuff soon. All right, thanks for watching, guys.